So here's one example. New materials are being developed to convert photons. Photons are the energy associated with electromagnetic radiation, or light, to high enough energy electrons to break water to yield the hydrogen gas. So this is just an example of a device. Again, you've got the water, and at the anode you are going to produce oxygen, and at the cathode you're going to produce hydrogen, which is what we want. And it's a way of taking sunlight, the photons just from sun. So this would be an example of using a solar type of a cell, and a very specific application here where the sunlight, the electrons from the sunlight are absorbed by a material that absorbs sunlight. Water doesn't, so that's why it looks clear, but a lot of other things do. So it's a metal oxide that absorbs sunlight, and when it does, the electrons in the metal oxide are promoted to a higher energy, which then drive this current, which then produces the hydrogen gas. Okay, so it's a very ingenious way of using the energy from sunlight to force this electrolysis of water, which in the ultimate end produces hydrogen. So there's a lot of research going on. A lot of smart people are working on ways to try to extract the hydrogen from the water without using other energies such as heat or electricity. This way, we've got the sunlight all day long, so you're using this free source of energy to make this happen. So millions and millions of dollars, because the payoff is going to be huge. If they can get this to work, then it would allow the fuel cell technology to just take off. Billions and billions of dollars worth of money could be made there. All right, so there's active research right now. That's the moral of this story. Getting the water would be the best place to get the hydrogen from. We saw it's energetically very, very expensive. So the research now is focused on, among other things, it's focused on figuring out a way to get the hydrogen off the water in a relatively energy cheap way. All right, so the hydrogen fuel cell is promising clean energy. Many hurdles to overcome. So it's active areas of research right now. A lot of companies are investing a lot of money, as well as the state and local governments. The deal is we got to produce enough hydrogen to supply the demand that will be as the technology comes along. There's a lot of research on how to transport it. Okay, just if you transport it in a cylinder, you guys have seen gas cylinders before. Those are heavy, so it's energy expensive to move it around, and you can only move it around in limited quantities, however much gas you can get into a tank. You could try transporting it as a liquid, but to get hydrogen gas into the form of a liquid, you have to chill it all the way down to negative 253 degrees Celsius, which is colder than liquid nitrogen. It takes a lot of energy to cool that down enough to hold it in the liquid form, so that's energy expensive. You can't pump it around. Like right now we have all these natural gas pipelines underground. Wherever there's development, there's natural gas pipelines. But you can't pump hydrogen in the natural gas pipelines because the hydrogen is more reactive and corrosive, and the pipes just would not be able to handle it, and they would break down and you'd have leaks and explosions and whatnot. There's other research going on because remember, the problem here is once you produce enough, then you got to get it to the point, the source where people want to use it. So the big research now is to adsorb, and the word adsorb means to stick to the outside of. So the hydrogen gas then would stick to carbon or metals, and it would be safely affixed to the carbon or the metal until the pressure changes or the temperature changes. And when you need it, if you change the pressure or the temperature when it's stored in this way, then the gas will just bubble off of the source, and then it would be released at the point that you needed it. But anyway, there's still a lot of research time and research dollars is going into solving all these problems. They're all being worked on simultaneously. But once these problems are solved, then a hydrogen economy is what's thought to be the fuel economy of the future. Whereas now we think of natural gas, petroleum, and coal. In the future, maybe 50 years, it'll be hydrogen economy. Okay, so that's it on the fuel cells. That's all I want to tell you about that. It's real interesting, active research. There's more and more prototypes coming online all the time. It's a big business. And the last lecture in this unit, we're going to talk about solar energy.